Hi, welcome all. Once again, I am welcoming you back. Welcome back, all the students. Now, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. So now we are happy to announce that Unacademy is going to providing training for GATE and engineering service examinations with India's top educators. Okay. Yeah, now it's okay. So India's top educators are handling the subjects here. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, here we check first how to get Unacademy learning app into our device. Just go to Play Store, type Unacademy in that, then you get the Unacademy learning app like this. Now, by clicking this install button, you will get the Unacademy learning app into your device. See here, I am going to showing you some of the top educators from Unacademy. Tiwari sir, he is the IIT topper. Ankit Goyal sir, he got 2 times All India first rank, and he was awarded President of India Gold Medal in IIT Indore. Sanchit Jain sir, he has a more than 8 years of experience and has sound experience in teaching these subjects to the students. Jaspal Singh sir, he is the ex-IAS officer. He got All India 4th rank. And he is the ex-senior MADESE faculty. Ex-senior MADESE faculty. Okay. So, because of these things, we are claiming that our educators are the top educators. Now, here are the few more top educators from Unacademy. So, recently, scholarship test of worth 1.8 crores is completed in Unacademy in the month of March itself. It is on 21st March 2011 at 11 a.m. conducted the test. Now in this largest front nightly competition for GATE, it is you can assess your GATE preparation in 60 minutes, challenging original GATE questions, challenging and original GATE questions curated by the best educators. It was curated. Now the eligible batches are mechanical, civil, computer science and IT department. Now take it live to compete with the best and super fast and fun with All India live leaderboard, and identify and improve your weak areas through detailed video solutions. Okay, so don't forget that if any competitive, any live exam is there, attend that and test yourself where you are, because All India ranking is provided here. So you need to get a best All India rank, then only you will get in the final examinations. Now, for engineering service examinations, ESE 2021 test series is going to be conducting in Unacademy. It was curated by the best educators. All India live ranking is provided. Okay, if test is taken live, and it was designed as per the changing demand for engineering service exam. In the 10 questions they will provide and 20 minutes of time. So for mechanical engineering is 22nd and 29th March, electrical 23rd and 30th March, for civil 24th and 31st March, electronics and communication engineering 25th March, and general studies it is on 26th March. And there is a full length mock test also available. This is for 150 questions, 180 minutes of time. This is on 21st and 28th of March at 10 a.m. This is for mechanical engineering, electrical engineering, civil engineering, electronics and communication engineering students. Now, so crack engineering service with Jaspal Singh sir. This is for civil engineering students especially. Join us for free test series. These are the topics and the test date. Test series date. This is the date. Don't forget to use my code VRAO10 during applying for exam. Now, ultimate 10 SSC series is there. In this 10 questions and 20 minutes of time we provided. These are the dates for mechanical engineering students. 1st, 4th, 9th, 12th and 17th of March. The timing is at 10 a.m. And even though date is completed, you don't worry. Here you can take the test and attempt even after the live test session also. Even after live test session also you can take the test. Okay, that facility is there. Now this is for electrical engineering. Dates 2nd, 5th, 10th, 15th and 18th of March. Timing is at 10 a.m. Now this is for civil engineering students. 10 questions, 20 minutes of time. Dates 3rd, 8th, 11th, 16th and 19th of March. Timing is 10 a.m. Now you can attempt the test even after the live test session also. And GATE, kickstart your GATE 2022 preparation. This was prepared by best educators. All India live ranking is provided if test is taken live. Designed as per the changing demand for GATE. Now in this 10 questions, 20 minutes of time for mechanical engineering, electrical, computer science and IT, chemical engineering, electronics and communication engineering and civil engineering students. On every Tuesday, Thursday, Saturday and at 10 a.m. And one more thing, every day, every week, 3 times exam is conducting. 3 into 10 questions, 30 questions every week you are going to be preparing. If you prepare every week 30 questions, per month 120 questions. Per month 120 questions. If you take 10 months continuously, now 1200 questions you get. If you prepare these 1200 questions effectively, then no doubt at all you will be one of the topper, all India topper. Now we are happy to announce that recently we started 2 new batches for GATE in different departments. One for GATE 2023, other one is for GATE 2022. And the faculty who are handling the subjects for GATE 2023, the same faculty are going to handling the subjects for GATE 2022. Now first we move to mechanical engineering. For mechanical engineering, there is a Ascend batch for GATE 2023. It was started on 22nd February 2021. And thus there is a Evolve batch for GATE 2022 for mechanical engineering students itself. It was started on 22nd February 2021. And there is a mission DDR going on for mechanical engineering students with the top faculties. Tiwari sir, Mameshwara sir, Menugupta ma'am, Aman Rao sir. Here are the top educators in this batch, and this batch was started on 22nd February 2021. This batch was started with the intention that every student in this batch has to got a good rank. With that intention it was started. And there is a Spark batch going on for civil engineering students for GATE 2022. This is English batch. This batch was started on 22nd February 2021. Now we move to civil engineering. For civil engineering, there is a Ascend batch for GATE 2023. It was started on 8th February 2021. Okay, and these are the team of faculty who are handling the subjects in this. Now we move to evolve batch for GATE 2022. There is evolve batch for GATE 2022 for civil engineering students. This batch was started on 8th February 2021. The same faculty who are handling the subjects for GATE 2023, the same faculty are handling the subjects for GATE 2022. Next, there is a evolve batch for GATE 2022 for computer science and information technology students. So in this, Ravindra Babu sir is there, Sanchit Jain sir, already given the credentials of him, and Ravindra Babu sir is the All India first faculty who started online training for GATE in computer science. Okay, now this batch was started on 8th February 2021. Now we are moving to electrical. So there is a large team, you observed or not, in electrical. Because more number of subjects is there in electrical, because of that there is a lengthy team. So this is the team for Ascent batch GATE 2023, and it was started on 1st February 2021. Now there is a evolve batch for GATE 2022 for electrical engineering. It was started on 1st February 2021. The same team, the team who are handling the GATE 2023, the same team is handling the GATE 2022. Now we move to electronics and communication engineering department. In that there is a Ascend batch for GATE 2023. This batch was started on 1st February 2021. So the faculty who are handling the 2022 and 2023, same faculty are handling both the batches. This is the electronics and communication for GATE 2022. Okay, this batch was started on 1st February. Now last but not least, we are moving to chemical engineering department. So there is a evolve batch for GATE 2022 chemical engineering. This batch was started on 25th January 2021. Here are the team members, team of faculty. Okay, now just we glance what are the different engineering disciplines available in Unacademy for GATE and engineering service examinations. ECE, chemical engineering, mechanical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. These are the top batch available in this. Now there are two subscriptions available. One is plus subscription, second one is iconic. Plus subscription is the basic plan, and iconic it will take your preparation to next level with the personal coach. We are providing a personal coach to you. Now what is the function of personal coach? I will explain. See here, India's best educators are handling your subjects. There are interactive live sessions are there, and structured courses and PDFs, and live tests and quizzes are there. Here also same thing. Now here we are going to differentiate you. Once you've written some test or quiz attempted, your personal coach is going to analyze your test. That is called personalized test analysis. Whatever the test you've written, it was analyzed by your personal coach. Based on that, they will prepare a proper study planner to you, and they will prepare a respective material to you. They will provide. By following these two, every student can get success in their examinations. That is the iconic plan. Now just we check the subscription cost for each and every plan. Now for plus plan, the subscription cost is it is available in 1 month subscription, 3 month subscription, 6 months, 1 year, 1.5 year, and 2 years. For 1 year it is 30,250. Okay, by using my code VRAO10 during subscription, you get it by 27,225 rupees. Okay, and don't forget to use my code VRAO10 during subscription. Its cost is 27,225 only. Now if you compare this cost with If you joined outline outside for offline training, the transportation charge throughout the year is 20,000 plus. Okay, just by adding a little bit amount to that, you can complete your online training by staying at your home itself. You can complete your GATE training just by staying at your home itself. So my dear students, please think of it and take a right decision. Just this is a nominal cost. Now we are going to Iconic plan. So this is available in two subscriptions, 1 year and 2 year subscription. For 1 year subscription, it is a 50,250 rupees. For 2 years, it is 74,000. Now by using my code, you get it by 10% discount, 45,225 rupees. My code is VRAO10. Don't forget to use my code. And one more, this cost is more or less the amount what you have to pay at outside for offline training. Some of the institutions or organizations are collecting the fee more 1.5 times or 1.6 times of that amount, 45,225. Okay, just by paying that amount only, you can stay at your home. You can listen the classes of India's top educators classes. Already Jaspal Singh sir, he is the XIS faculty, XIS and he is the XIS officer, All India 4th rank, and he is ex-Medici faculty, senior Medici faculty. Like that type of faculties are there. So you can listen their classes by staying at your home itself. Okay, and especially we are providing a personal coach to you. That personal coach plan to you is going to be more benefited to you. So my dear students, please think once of it and take a red decision by discussing with your family, friends and faculty who are having knowledge on GATE and engineering service examinations. Please discuss once with them and take a right decision. That decision will change your life into a beautiful direction. Okay, you should say you should be in a good position. That is our intention. Now thank you, thanks for spending your time with us. Now we are moving to our today's topic is MOSFET. Already we completed some topic, just I am going to showing these slides. See, already these topics are we completed. Introduction about construction of MOSFET, how it is. Okay, how to form the channel. Okay, and some information during the formation of channel, what we are doing, and minimum threshold voltage, minimum gate voltage required, that is threshold voltage. Once keeping VDS constant and varying VGS, what happens? And VGS keeping constant, VDS is varying, what happens at different conditions. Okay, now different regions also we completed. Now the shape of the channel is very important, plays a very important role here. This is the shape of the channel. This is the shape of the channel by varying the VDS, and this is the equation for, this is the plot for drain characteristics. And after that we go for, just we defined here what is oxide capacitance or what is MOS capacitance, what is gate capacitance we defined here. And after that we started to derive the equation relation between VDS and IDS. Okay, IV relation. IV relation in MOSFET, voltage current relation in MOSFET. Okay, just we defined IDS, it is a drift current, because of VDS only we are getting the current. So drift current density into area of the channel. Okay, now this is the rho V and volume, cross sectional area, everything. Now I substituted all these things in your IDS. Finally we got this equation. Okay, now under these conditions our channel is like this. See this, our channel is like this. Channel is like this, and we are applying the VDS value. Here VDS we are applying. Okay, now this is the length of the channel. Length of the channel L. That means at source, and this is source and this is a drain end. Okay, if you check it, this is the plot I am taking on VDS. This is the okay. This is VDS and this is L length, channel length L. Okay, let us take X distance X. Now VDS is a function of X. That means VDS is varying from here to here. VDS is 0 here, VDS is maximum here, and VDS is varying from here to here like this. Like this. At a distance of X equals to L, VDS value is equals to VDS, whatever the value we applied. Now I am going to applying integration to that equation. Previously whatever the equation here we have, for that I am going to applying integration. Now see this. This is the equation what we have. IDS is equal into dx equals to mu n into cox into w into that VGS minus VTH minus VDS into V of x. Sorry, V of x, sorry. It is V of x into dV. Now I am integrating on both sides. Here dx is there and here dv is there. So once dx distance you need to take. Now this is the plot just before we got. This is the voltage plot and this is the distance x, and your plot is, this plot is like this. Voltage variation on a channel. Now it is the VDS. Now at x equals to L, at a distance x equals to L, x equal to L, voltage V became VDS. Voltage across the channel is VDS. So now the limits here I am taking 0 to VDS. Sorry, it is a dx on x-axis, limits 0 to L. It is a dv, so limits on is 0 to VDS, voltage limits. Now IDS is a constant, therefore IDS is into integral 0 to L dx is equals to, here mu n into cox into w is constant, and integral 0 to VDS into VGS minus VTH minus V of x into dV. Okay, now see this. So this is IDS, integral dx is x, limits 0 to L, mu n cox into w, integral of VGS minus VTH is a constant value, integral V into, it is constant, integral dV. So this is VGS minus VTH into integral dV is V, limits are 0 to VDS minus integral v of x dv. That means it is v square by 2 limits are 0 to vds. Now I am doing the same thing, just I am substituting the values in this. So it is IDS into L minus 0 equals to mu n COX into W into VGS minus VTH into VDS minus 0 minus, it is 1 by 2 into VDS minus VDS square minus 0 square, that is V square ds by 2. Now therefore finally we get IDS into L is mu n into COX into W into VGS minus VTH into VDS minus V square ds by 2. Now I am taking this L this side, therefore finally IDS is written as mu n into COX into W by L into VGS minus VTH into VDS minus V square ds by 2. This is the equation for IDS. This is the equation for IDS. So IDS is mu n COX into W by L, VGS minus VTH into VDS minus V square ds by 2. This is the general expression. It can be applicable to both ohmic and saturation region. Therefore, it is the general expression. Expression for IDS. Okay. And it is applicable to both, applicable in both, ohmic and saturation region. Both ohmic and saturation regions. Now we apply the same thing in ohmic and saturation regions. Now first I am taking this one into ohmic region. Ohmic region. So in ohmic region we know that VDS is small. VDS is small. Therefore V square ds by 2 is very small. Very small. That means it is negligible. So once we neglect that, therefore IDS is approximately mu n COX into W by L into VGS minus VTH into VDS. This is the approximate value of IDS in ohmic region. And in ohmic region, we are using your MOSFET as a resistor. Now the resistance between RDS in ohmic resistance, ohmic region is VDS by IDS. VDS by IDS. So it is just 1 by mu n COX into W by L into VGS minus VTH. This is the amount of resistance it gives. Okay. This is the equation for that, and I am writing that RDS. So RDS is 1 by mu n COX into W by L into VGS minus VTH. That is the equation for RDS value. Okay. So in ohmic region, it is used as a resistor. And the resistance value is this much. The resistance value is this much. That's it. That is about ohmic region. Now we are moving to saturation region. This is the equation. Now we are operating this one in saturation region. So in saturation region, we know that the condition for saturation is is VGS minus VTH should be equals to VDS. Now in place of VDS, I am substituting this value. Okay, therefore IDS is mu n COX into W by L into VGS minus VTH as usual. In place of VDS, I am taking VGS minus VTH minus VGS minus VTH whole square by 2. Now it is therefore IDS is mu n COX into W by L into VGS minus VTH. Just I am simplifying, sir, not more than that. Whole square by 2. This is the equation for IDS in saturation region. Equation for IDS in saturation region. Okay. Sir, is it okay? Now we are moving to the applications of MOSFET. Just a brief information about applications of MOSFET. EMOS. See, first one is it acts as a switch in saturation. See, here if VGS is equals to 0, no channel, we discussed already. Once no channel, IDS is equals to 0. IDS equals to 0. So it is the off switch. Off switch. So here it behaves like a off switch. Okay. Now if I am taking VGS is large value, large positive value I am taking, let us. Large positive value in MOSFET is approximately equals to, that is VDD. In digital electronics we use generally this is. In digital electronics only we are taking VDD, sir. In digital electronics only. VGS taking the large value in digital electronics only. Okay. Now once VGS is large value, large channel we have, so high conduction we get. So therefore, so once VGS is large value, so channel with good conductivity. So we have a channel with good conductivity. Channel with good conductivity. Okay. Now once it is good conductivity means you can consider it as a on switch. On switch. You can consider it as a on switch. So this is the switch operation. So next we are moving to second one, amplifier. It can be used as an amplifier. For amplifier, so when it is operating in, when EMOS is operating in saturation region or pinch off region, both are same, sir. Pinch off region, it can be used as an amplifier. Can be used as an amplifier. Okay, here what we can observe is, in saturation region, just before we written an equation in that. In saturation, IDS is, in saturation the equation for IDS is mu n COX into W by L into VGS minus VTH whole square by 2. See, by changing the VGS value, IDS value is changing. Okay, so change in VGS produce proportional change in IDS. Proportionate changes in IDS. Okay, so which produces high changes in VDS. Once change in VGS, VDS also changing, which produces higher changes in VDS. So in observe, we can observe this one in amplifiers in detailed. Okay, so this is the another application, second application. Third application is voltage dependent resistor. You can use this one as a voltage dependent resistor. Voltage dependent resistor. See, in ohmic region, what we've written? In ohmic region, we've written IDS value is approximately mu n COX into W by L into VGS minus VTH into VDS. And from this, I am writing drain to source resistance RDS is VDS by IDS. So, which is equals to 1 by mu n COX into W by L into VGS minus VTH. What it means? By changing the applied input voltage, VGS, RDS is changing. So this voltage dependent resistor, this resistance value depend on voltage, input voltage. That is the meaning of that. Therefore, here RDS is changing by changing VGS. By changing VGS. Therefore, RDS dependent on VGS. Therefore, RDS dependent on VGS. So, this is the voltage dependent resistor. This is the third application of MOSFET. Okay. Now, next one. Now we are going to very important thing is symbols. Symbols are very important. We are at a device level, that's why we are not much concentrating on symbols. Practically, once we are moving to the biasing and amplifier section, there we need to draw the circuit symbol continuously. Okay, now symbols. Symbols for EMOS. Symbols for MOSFET. First one is this is the way of writing the symbol. This one. This is one symbol, and another one is like this. And another simple way is this is the another simple way. Gate, drain, source. In case of this, it is a source, drain, gate, and drain, source, gate. This is the substrate. It is the substrate. It represents a substrate. Substrate. It is also substrate. So substrate always shorted to source. Shorted to source. And you observed or not, here drain and source both are shorted. Both are connected directly. So in depletion MOSFET only we have a channel. That channel is going to be shorting both source and drain, connecting both source and drain. Okay, so this is the depletion MOSFET. This is D MOSFET. DMOS. Okay, default it is N channel. N channel D MOSFET. And there is an arrow mark indicates that if the substrate to channel is in forward bias, the direction of current indicates this arrow mark. And these two are the E MOSFET, symbols for E MOSFET. N channel EMOS. And here is an arrow mark. And source, there is an arrow mark. Okay, this is the representation of, symbolic representation of E MOSFET. Okay, so far we know the operation of this as well as its way of representing. Clear? Next. So after that we have one concept, that is a channel length modulation. Now we are going to that concept. Okay, so already we observed while increasing the VGS, VDS, see this. Yeah, here by increasing the VDS, what we observed is length of the channel is going to be decreasing. Length of the channel is decreasing, we observed there. So that is the channel length modulation. Okay, now we go and discuss about that channel length modulation. Okay, so next topic is channel length modulation. channel length modulation. Now, so this is the MOSFET what we have. This end we have n plus, we have n plus diffusion here. Now there is a oxide layer upon this, and above there is a metal. Above there is a metal. So here source, drain, source is source shorted, ground source. At the drain end we are applying VDS. Okay, now at gate it is. At gate I am applying VGS. At drain the voltage is greater than VGS minus VTH. Okay, this is the condition I am going to be applying. Copying the so this here I am taking VDS is greater than VGS minus VTH. Initially we have a channel like this. This is our initial channel. Channel is like this initially. This is length of the channel L. Once you are increasing VDS, now the channel is decreasing. This is your channel. This is your channel. This is your channel. And the length of the channel in this case is this much. L dash. Length of the channel is L dash. And the channel what we lost here is compared to L, this is delta L. Delta L. Now L is equals to here L dash plus delta L. L dash plus delta L. Okay, now here delta L is the amount of channel what we are going to be losing. Okay, now so we can write that is where delta L is directly proportional to the VGS minus effective gate voltage or V effective. effective gate voltage. Okay, and here V effective voltage is nothing but a VGS, sorry, it is VDS, sir, not VGS. VDS minus effective, so it is VGS minus VT. Okay, so if VDS is increasing, delta L is going to be also increasing. That is the meaning of that. Okay, now under these conditions with length, actually your IDS equation is, IDS saturation I am taking is mu n into COX into W by L into VGS minus VTH whole square by 2. This is the equation for IDS saturation. IDS saturation. Under saturation conditions, this is the equation for drain current. With length L, don't forget that this is the length L here. This is the length L. Length is L here. This is the length L. And it is, sorry, it is by 2. Now channel is decreasing here. This is the, so once you are applying, it is greater than VGS minus VTH. Your channel is like this. Your channel is like this. And just before you mention, this is your delta L. Delta L. This is L dash. And this is L, we know that. Now under these conditions, with this channel, with this much amount of channel, IDS is mu n into COX into W by L dash, W by L dash, because only channel is L dash, and I am taking this is IDS, okay, into VGS minus VTH whole square by 2 by 2. Okay, this is the equation under these conditions. Okay, time up. Next session we complete the remaining part. Thank you. Thanks for spending your valuable time with us. Don't forget to use my code VRAO10 during subscription. Hit the bell icon for getting notifications. Don't forget to subscribe us. Join our Telegram group for getting latest updates on our upcoming videos. And please give your valuable comments on YouTube. Thank you. Thank you very much. Thanks for spending your valuable time with us. And once again, I am welcoming you all to this beautiful online learning platform, Unacademy.